Hey everybody. Apparently I start every video with, quote, "Hey everybody," end quote, but I didn't know that. Now I know that. I've noticed it. Anyway, we're going to be going over each of the problems, and if you don't need to see each of these mixed circuit problems, then fast forward to the next one, but we'll start with the first one. And the first thing you're supposed to see that we're going to combine is the 20 and the 80. So the 20 and the 80 is 1 over 20 plus 1 over 80, which is 16 ohms. Now, again, some of you may know that you're going to be doing the 16 and the 24 in series, but you can't do that in one step. You must redraw. Simple as that. I'm going to redraw my circuit here. I got my 24. I got my 16. So I have 24 ohms, 16 ohms. Next step is clearly that I'll be putting these two in series. I'm just going to do that one over here. And those two in series become 40. So that's 40 ohms. All right. So now we know that there's 100 volts on the source. We want to know the source current. So the first thing you're going to do is find the source current. V source over R equivalent, which is 100 volts over 40 ohms, which gives you 2.5 amps. So what we do now is we know that there are 2.5 amps going through this resistor, and we also know that the voltage on that resistor is 100 volts. From the previous videos, you're supposed to know that the questions you're supposed to ask are, when we went from this circuit here to this circuit here, what did we do? Well, we combined two resistors that are in series. What's the same in series is the only question you ask yourself. These two resistors became this resistor. So what's the same in series? The current. So if the current for the 40 ohms is 2.5, then that's what the current is on this one and this one. Now that we have the current, we can quickly solve for the voltage using V equals IR. That'll give us 60 volts for this one, and it'll give us 40 volts for this one. The 24 is now one of your original circuits. It's all done, so we're done with that. Now the next thing is working backwards again. When we went from this circuit to here, we combined two that were in parallel to become 16. What's the same in parallel? The voltage. So whatever the voltage is on the 16 is the voltage you're going to write here next to the 20 and the 80. And then once we've got the voltage, we can solve for the current, which would be 2 amps and 0.5 amps. And that's the first one, the easiest of the three. All right, for the second circuit, hopefully you saw right away that there's a few things we can combine. We can combine the 15 and the 5 in series. That's easy. That's just going to become 20. And then the 50 and the 150 are in parallel. So quickly doing that math on the side here, if you need to, it's 1 over 50 plus 1 over 150 gives us 37.5 ohms. Okay. Then after that, we should redraw the circuit. So I'm going to do that here. Why not? So I've redrawn the circuit, which is a must. If you're not redrawing circuits, you're never going to make it. After that, the only move you have right now is to combine the 22.5 and the 37.5 in series. And some of you may then know that you'll be combining that with the 20 in parallel, but you must redraw the circuit. You can't do series and parallel in the same step. I mean, you can do series and parallel like I did in the first one, but you can't combine these two resistors. Then after that, combine it with another resistor, all in the same step. So I'm going to redraw that one. That shouldn't take too long. We've got our 90 volts. We have the two that are in parallel. So we've got 20 ohms down here, and we've got, can't do math all of a sudden, 60 ohms here. Afterwards, it's clear that these two are in parallel. So that's going to be 1 over 60 plus 1 over 20. 1 over 20 plus 1 over 60 gives us a resistance of 15 ohms. Now, you really need to redraw this last circuit. People that skip this step Have more trouble than not. Don't be lazy. Just redraw. It takes 2 seconds. Look, I just did it. 15 ohms. We know the voltage on the source is 90 volts. 90 volts. Which also means that the voltage here is 90 volts. And of course, what you want to find is the current coming out of the source. So I source is the voltage of the source over R equivalent, which is 90 volts over 15 ohms, gives us a current of 6 amps. So we now know that the current flowing from the source is 6 amps. All right, time to start working backwards. We went from this circuit to the final circuit. We combined the 60 and the 20 in parallel. What's the same in parallel? In parallel, the voltage is the same. And if the voltage on the 15 is 90, then the voltage on both of these is 90 volts, 90 volts. Once we have the voltage, we can solve for the current, which is just V over R. So that gives us 1.5 amps here and 4.5 amps here. All right, that one's done, but none of them are original resistors. So now we look to see what we changed when we went from this circuit to the third circuit. And it looks like we can combine these two that were in series to make the 60 down here. So what's the same in series? The current. If the current on the 60 is 1.5 amps, then guess what? The current on each of these is 1.5 amps, 1.5 amps. Now that I know the current, I can solve for the voltage. So 1.5 times 22.5 is 33.75 volts. And the 37.5 times the 1.5 is 56.25 volts. Turns out the 22.5 is one of your original resistors. So I can circle it and put that information in the chart. All right. Last one. When we went from the first circuit to our second circuit, which is this big one here, and went over here, we combined a few things. We did the 15 and the 5 to become the 20. Those two are in series. So whatever is true for the 20 is true for the 15 and the 5. So since they're in series, that means the current's the same everywhere, which means I can write 4.5 amps, 4.5 amps. And now that I know the current on each one, I could solve for the voltage of each one, which would be 67.5 volts and 22.5 volts. Those two are original resistors. I'd circle them and say, yep, put that information in the chart. Also, we combine the 50 and the 150 to become 37.5 over here. They are in parallel. What's the same in parallel? Voltage. So whatever the voltage is on the 37.5, that's the voltage on the 50 and the 150. So I can write 56.25 volts, 56.25 volts next to each one. Once I have the voltage and the resistance, I can solve for the current. And the current for the top one's around 1.13 amps, and the 150 is about 0.3 amps. Both of these are original resistors. So we can circle it and put that information in the chart. There you go. And we move on to the third and final circuit. All right, the third and final circuit. A few things you can do right here. Right away, you should see that the 70 and the 10 are in series, and the 30 and the 60 are in parallel. So those should be pretty straightforward. I don't know if you need to see the math for the parallel, but it is simply just 1 over 30 plus 1 over 60 gives us, I believe, 20 ohms. You must redraw the circuit. If you're not getting this, that's the reason, probably because you're not redrawing every step of the way. I thought I made it clear in the videos, but every year there are people that just fight me on this, and they're like, no, I can do it my own way. No, you can't. This is the way to do it. Just do it this way. Get everything right. Enjoy. So this is now 80 ohms, this is 20 ohms, and this is 34 ohms. Our next step. You only have one move, actually. They're not all three in parallel. That doesn't make any sense. That means that the current splits at a junction. You're saying that the current splits here and goes into 3 different resistors. It doesn't. It splits here and goes into the 80 goes into the 20 and rejoins over here. So the 80 and the 20 are in parallel. Please make sure you get that. Just because they're across from each other doesn't make them parallel. So these two are in parallel. You do the math over here. That's 1 over 80 plus 1 over 20 gives us, all of a sudden, I don't have the ability to do math, 16 ohms. You must redraw the circuit again. I know some of you know that it's in series with a 34. I don't care. Redraw. If you're not redrawing, you're not going to get it right. Simple as that. Oops. I lost a resistor there. Lost the whole circuit there. Try that again. That's 34 ohms up here, 16 ohms down here. These are in series with each other, not parallel. Just because they're across from each other doesn't make them parallel. The current goes around, never has a choice where to go. So those are in series with each other. So the last step looks something like this, with the two of them together to become 50 ohms. And we have a voltage of 100 volts, so I can put that here, which also means that the voltage here is 100 volts. And again, your next step is to find the current coming out of the source. People that don't do this last step where you draw this last circuit and solve for that source current, they don't get it. You just have to do this. Please trust me. Don't be lazy. Follow the procedure. Get the answers right. So that's, you could do this in your head, but 100 divided by 50 is 2 amps, which means that there is 2 amps on this circuit. Yippee! Time to start working backwards. When we went from this circuit to the final circuit, we combined 2 resistors that were in series with each other, and they became the 50. What's the same in series? The current. So if the current on the 50 is 2 amps, the current on each of these is 2 amps. Now that we know the current and the resistance, we could solve for the voltage. This down here is 32 volts. This one up here is 68 volts. And this is one of our original resistors. So that one goes in a chart. All right, now it's time to go from this circuit to here. When we did that, we combined the 80 and the 20 to become the 16. The 80 and 20 are in parallel, and they became the 16. What's the same in parallel? Voltage. Well, then the voltage on the 16 is the same as the 80 and the 20, so I can write 32 volts, 32 volts. Once I have that information, I can solve for the current. So give me a second there. Sorry, that's going to be 0.4 amps and 1.6 amps. And finally, when we went from our first circuit to our second circuit, we combined the 70 and the 10 to become the 80. 70 and the 10 are in series. What's the same in series? Current. So if the current on the 80 is 0.4, then the current on each of these is 0.4 amps and 0.4 amps. Once you know that, you could solve for the voltage. This one would be, all of a sudden I can't do math. Is that 4 volts? It's 4 volts. And this one is 28 volts. Yippee! Those are 2 original resistors. I'll circle them and say they're done. And then take that information, put it in your chart. After that, what else do? We combine the 30 and the 60 to become the 20. The 30 and 60 are in parallel, so voltage is the same. Take the voltage from the 20 and write it right next to the 30 and the 60. That's 32 volts, 32 volts. Once you have the voltage and the resistance, you can solve for the current. So this is 1.07 amps, and this is 0.53 amps. Those are both original resistors, and that's it. That information goes in the chart, and you're done. If you have any questions about this stuff, please don't hesitate, because hesitate to visit me for office hours, because we're doing this again in the next homework. So I hope you're all doing well, and take care.